So if you want to measure the time period of a pendulum, so what we will do first, we will, because we are using a stopwatch, so the points here, reset the stopwatch. Because your stopwatch, maybe it was used for another experiment, so it's having some value. So always reset the stopwatch. Then we will mark or identify mean and extreme position. Mean position, how you can mark a mean position? When a pendulum is not vibrating, that's a mean position. The last point where you took or you moved the pendulum, that is called an extreme position. Then we will release the pendulum. From its extreme position. Mean position or the center position. Like here in the picture, you can see the center position. When the pendulum is not vibrating, we call that position as a mean position or center position of pendulum. So we'll release the pendulum from its extreme position and start the timer. Timer or the stopwatch. Then what we will do, instead of recording time for one vibration, because when we are recording a time for one vibration, maybe that's not accurate because it's a too short time interval. So record time for like 20 vibrations or 10 vibration or 15 vibration. It's up to you. It should not be too small or too many. Like I cannot record the time for 500 vibration. Maybe a pendulum may stop vibrating or it's difficult to count the whole 500 vibrations. So record time for 20 vibrations. Then time period. How to find a time period or time for one vibration? Is equals to total time divided by number of vibration. And then repeat the experiment for accuracy. So these are the points which you should consider when you're writing or planning experiment to find the time period of a pendulum. So first you should reset the stopwatch. Like if there's a stopwatch, you will reset the stopwatch. Reset the stopwatch means it should have 0 in the beginning. All the numbers should be 0. Then you move the pendulum, you will mark mean and extreme position, like you should know what is the final position and what is a mean position. Reason for identifying mean or extreme position, so you can know when it is completing its vibration. Then you will release the object or the pendulum from its extreme position, like I release from point B. And at the same moment, I will start the timer. So when it will move from, when I release, it will move from B to A and then A to C and then return back. That's one vibration. Then again, it will go and return back, 2 vibrations, 3, 4, 5, 6, 7, 8, 9, 10, and so on till 20 times it's vibrated. So I will get the time for 20 vibration. Example, the time for 20 vibration was So time for 20 vibration example, it is 50 seconds. So 20 times it vibrated in 50 seconds. But the question is how to find a time period. Time period means time for one vibration. So how I will find the time for one vibration? So what is the total time? The total time is 50. And how many vibrations are there? 20. So time for one vibration, total time divided by number of vibrations. So the total time here in this example, the total time is 50. And what is the total number of vibration? 20. So 50 divided by 20, which is equals to 2.5 seconds. Yes, Ahmad Umar, you have a question?
Miss, I want to ask, the vibration can also depend on the force the amount of force we pulled and
Yeah,
released the ball.
it depends on. So that's why we should not push the bob. We should just let it go. Instead of pushing the bob, because the time period will change if you push the bob or you apply more force or if you push it harder or so gently. So it's just like we release, like a pendulum is at mean position. We take the pendulum to its extreme position and we do not push it. We just release it. So when it will go and come back, that's called one vibration. So time period might change. These are the sources of error. What you mention here, this is a source of error that if an observer or a person or a student who is performing the experiment is pushing a pendulum, then the answer won't be accurate or correct.
So how much
Sir,
we should pull?
No, it's up to you. Length of, that's called an amplitude. According to a question, like example, it may have amplitude 1 centimeter, 2 centimeter, 3 centimeter. You can keep any amplitude. It depends on the experiment, but you're not doing the experiment. Basically, you are doing alternative to practical. So in alternative to practical, they will not mention like make the distance 3 centimeter or 5 centimeter. So it's not an issue. Yes, who was
And
asking? Yeah.
sir, won't this become inconsistent as the bob keeps on vibrating?
Yeah, so that's why we are not calculating for like 100 vibration or 50 vibration on average. This is, we are getting a time for average vibration.
Miss, how much we should check the time until it stops? Record the
No, no,
time.
not until it stop. Like example, time for 20 vibration. Maybe it will stop after 70 vibration or 30 vibrations, but we are only recording a time for 20 or 10 vibration or 15 vibration. Not too many, not too less. Yeah, there are errors in the reaction time because you think that you should start at the timer or stop. So there is an error of reaction time. But the thing is, the experiment, how to find a time period of a pendulum. So these are the things which you have to keep in mind. There are errors. I did not discuss the errors. I'm discussing the procedure now, like how it can be done. Any doubt in this experiment?
Sir, the
Yes. Yes, Afif.
pendulum, shouldn't it depend on other things like maybe the mass or the material of this bob?
Yeah, these factors may affect. These factors may affect, but this you can find practically only. Like it can, the size of the bob, the length of the pendulum, the type of a material pendulum made up of, the amplitude. Amplitude means the distance from mean position to extreme position is called amplitude. Like this distance is called amplitude, the horizontal distance, mean to extreme. So there are many factors which may affect the time period, but the main idea is how to find or how to plan an experiment to find the time period, not what factors may affect the time period or what are the sources of errors. The main objective of this experiment for you is how to find the time period. There are errors, there are factors which may affect. Is it clear?
Yes, sir, it's clear. Thank you.
Anyone having a doubt related to this? You can take a screenshot for this. I will share the recording also with you. So later, if anyone of you, if it's better, you copy the lecture as well. So you will have at the last, you will have lecture notes, so you can revise through those notes. And when you write something by yourself, you will have better understanding of the topic instead of just you took the picture, and if you'll not copy it, then it is not useful.
Sir, before ending today's lecture, can you also repeat the definitions of vibration and time period? Just the definitions.
Vibration, to and fro motion of an object. Like, you want me to orally revise or type?
No, I just only needed the definitions.
Vibration refers to and fro motion of an object. And time period, it's time to complete one vibration. So this is just the same thing. If we want to find the time period, so what we can do, we can reset the stopwatch, release the object and record the time for 20 vibration, divide the time recorded by number of vibration, repeat and take an average. These are the points which you have to consider when you will answer a question related to finding a time period.
Okay, Mr. Thank you.
So I'll end the session now, and we'll discuss new topic, mass, weight, and density tomorrow. So today topic is about how to find time period and how to measure a length using a micrometer and measure the volume of regular and irregular objects.